Okay, I wanted to continue on with the remainder of the lecture that I began last Thursday, talking more about research methods in psychology. This is an important section because I want to talk a little bit more about how we can do more things with experiments and also some of the considerations that need to be made when we do an experiment. So let's proceed on with this. So remember the example that we had in which I tested the hypothesis, or I presented a two-group experiment to test the hypothesis that fast talkers are more persuasive than slow talkers. Now, we could use correlational methods to get a handle on this kind of hypothesis, of course. So for example, we can see if there's a relationship using correlational methods. You might go out and sample some actual speeches, maybe political speeches, various kinds of speeches meant to be persuasive and to communicate and try to get people to change their attitudes. You could go out, sample some actual speeches. You can time the speaker and how fast he's talking. And then in turn, he or she is talking, I should say, and poll the audience for whether or not they agree with the message and the extent to which they do. You can then make a scatter plot, look at the relationship, getting a score both for the speed of speech of the speech that the participant listened to, the audience listened to, and each audience member's level of agreement with the point the speaker was trying to make. Okay, you could then compute the correlations between the length of the speech and the audience agreement ratings. Okay, so you could do this and maybe we'd find a fast relationship, but without an experiment in terms of doing this kind of correlational field study, and just going out and observing existing actual speeches, you've got some of the familiar issues with regard to a correlational or simply observing and obtaining data that way. So for example, suppose we do find that those who were speaking faster, that in those speeches that yielded, there seemed to be greater audience agreement. Well, you don't know if, so you might conclude, well, the faster the speech rate, the greater the agreement, so that speech rate is causing greater agreement. But it could be just the other way around, right? We might have people who tended to audiences that were favorable toward the speech, right? And they conveyed their agreement, and that compelled the speaker to relax and hence speak a little bit faster. So it could be that the audience agreement in this hypothetical correlational study was the cause of the faster speech or the level of, or the rate of speech. There can be third variables going on. Maybe the speech was less complicated, so therefore easier to deliver in a faster, better paced manner, and because it was straightforward, the content, the audience more readily agreed with it. So there's all kinds of third variable issues that could get involved here. So we get to our example from Thursday, which was this experiment, right? So we've already been through this, and just to review that very quickly, we did random assignment. Everybody in our sampling frame had an equal chance of being in one or the other condition. So we have random assignment, which is a form of control. We're ensuring that nothing that the participants bring to the experiment, that they don't differ in any a priori pre-existing way, which could explain the results we end up with. Then we ran the study. Participants in this group basically listened to a speech. Remember, the example was advocating mandatory senior comprehensive exams in order to graduate from our college. Okay, so that would be something people would probably begin their listening by being opposed to. So we have one condition in which they get a speech advocating that policy, that requirement. And in random sample B, our other experimental group, they get the fast speech version. So we know that normal speech is typically 150 to 160 words per minute. This group, the speech is recorded at about 120 words per minute, which would be fairly slow and deliberate. This speech, in this case, it's been recorded at 180 words per minute, which is a more rapid, but still normal sounding level of speech rate. So the important thing to keep in mind is that everything is exactly the same, okay, between what happens to these guys and what happens to the participants in the sample B. Okay, it's the same speech delivered by the same person. The instructions that participants are given to introduce the speech are the same. Everything is the same. Okay, the experimenter is the same. Everything is the same except for the speech rate. Okay. After they listen to the speech, as we saw, they're asked to indicate the degree to which they agree with it. So that's the dependent variable, right? That's the behavior that we're going to observe. The independent variable is what is manipulated. And so we compare agreement in this group versus this group. And so we would compute some statistics, and let's say that on a 15-point scale, where 15 equals maximum agreement with the message and 1 equals maximum disagreement, the average agreement was 7 in the slow speech condition, and it was 10 in the fast speech condition, right? Okay, so we've got a numerical difference which seems to support our hypothesis. The question is this a trustworthy difference? Now remember, we have random assignment up here, which is a random procedure, as we've seen, okay? And it does sort of give much greater assurance that the two groups are the same in terms of the composition, the types of people that are being studied in the two groups. But it is random, and so there could be, by chance alone, differences between these two conditions, between these two groups of individuals in terms of their that could create the difference here, 10 versus 7. Okay, so statistical tests can be conducted which yield a statistic known as the p-value. Okay, the p-value is the probability that the test basically crunches the numbers and gives the probability that this difference, a difference of 3 points, can be due to, it could be due just to chance random variation alone. Okay, and if the test yields a result that p is less than 0.5, then we consider the difference trustworthy, because that's saying that the probability that we could get a difference of this magnitude, 7 versus 10, on a 15-point scale with as many participants as we run, the probability that could just be a fluky chance difference is less than 5%. And if it is, we conclude that we have a trustworthy difference. Okay, so we went through that last time. So let's say it's significant, and that means that that result is not likely to be to chance. We can sort of trust the validity of it. Okay, so we've got some evidence, experimental causal evidence, that speech rate causes, that faster speech rate is associated with greater with more persuasion, with persuading people to agree with your message more. Okay, we have causal evidence because everything is the same before we got to this measurement point. except speech rate. So if we have held everything else constant, done our statistical tests and so on, and we get this difference, the only a reasonable explanation for that, the logical conclusion, is that speech rate, the fast speech, caused greater agreement. Okay. Now, let's revisit this topic. Now, there's one experiment would not make for a scientific conclusion that we could, it would make for the scientific conclusion of cause in that setting, but we would have to repeat this experiment and do different variations of it in order to increase our confidence that our hypothesis of a positive relationship between speech rate and persuasion was correct. So, and there are various shortcomings to this study, of course. Okay, so for example, we only have two groups, right? How do we know that slow speech didn't decrease persuasion because people were, the person conveyed lack of intelligence, lack of knowledgeability about the topic because he or she was speaking too slow, so slowly, okay? So we don't know if it was the slow speech that decreased persuasion or the fast speech that increased persuasion. One way around that would be to do a more complicated experiment where we have a third level of the independent variable, a moderate speech rate. Another possibility is that, remember, most things are true, at least under some circumstances. So the question is this a genuinely true relationship that transcends different situations? So we might do yet a more complicated experiment, and these are called factorial studies, in which we add a second independent variable. Okay. One hypothesis could be that the reason that fast speech is associated with more persuasion is that people use speech rate as sort of a clue or a cue as to whether or not the speech is credible and is itself based on good reasoning. Okay, so if a person is speaking really slowly and they're kind of hesitating and pausing a lot and seem very, very deliberate in their speech, it may sound as if they don't really know what they're, they don't have much of a grip on the topic, and we might use that as a cue that, oh, that's not such a compelling kind of argument. On the other hand, the fast speech suggests, oh, the person knows what they're talking about, this must be valid. So people might be using speech rate as a cue. Now, that is something that we would expect people to do under lots of circumstances because we get so much information and most of it isn't particularly relevant to us. So we don't, rather than really concentrating on the message, we look for these cues, okay, as to what's persuasive, what's not. If the message was extremely personally relevant, we might not get this relationship, because if it's a really important message that's relevant to people, okay, to the people listening to it, to the audience, rather than rely on the speech rate as a cue to persuasion, a cue to whether they should agree or not, they might actually get into the nitty-gritty and start analyzing the message for themselves, paying a lot of attention to that. So the relationship could be smaller or disappear when personal relevance was high. When we find that kind of effect, we're going to call that an interaction effect. We'll get to that in a second. Another thing that you want to do in experiments to get at the whys of a relationship is to measure other variables. So if the hypothesis is that the fast speech conveys credibility and the credibility of the speaker, we might want to ask questions afterward. How credible do you think the speaker is? How intelligent? How knowledgeable? If a speech rate affects those variables, those variables could be behind why we found the original relationship in the first place. So you can get fancy in an experiment. So I'm going to present the results of a hypothetical study and first and describe the experiment that got to them, which I think might be illustrative. So here's a study in which we actually have two independent variables, so it's called two factors, so it's a factorial study. So in this case, we have, we're going to have 6 conditions, okay? Participants are either going to hear the message as in the procedure we've seen, either slowly presented, 120 words per minute, moderately presented, our new level of speech rate, 150 words per minute, or the fast speech that we had in the first experiment, 180 words per minute. And participants in each of these speech rate conditions are going to get the message either under high, right there, or low relevance conditions. So how will we manipulate relevance? Well, remember the message, the hypothetical message in our hypothetical first study was basically proposing and advocating that in order to graduate from John Jay College, okay, you would need to pass a comprehensive exam in your major. Very counterattitudinal. So what we're going to tell half of the people in this experiment is that, and that'll be our low relevances, this is actually, before they hear the message, we're going to tell them what the message is going to be about. We're going to say, but this is a policy that's being considered by CUNY, and if it kicks in, it won't kick in for another 6 years. Okay, so it's low relevance. It's not going to affect most of the people if they're John Jay students, okay, who are going to listen to the message in the experiment. So that's our low relevance condition. In the high relevance condition, we give the same spiel, but we tell people that actually CUNY is considering this and this policy, and it's conceivable that it could go into effect next year, in which case virtually everybody listening to the message, unless they were a graduating senior from John Jay, would find this highly relevant. So we present the message just as we did with everything held constant, either slow, moderate, or fast under low or high relevance conditions. And these are our results on the agreement scale, okay? And as you can see, when we have low relevance, we get the same kind of effect, okay, that we had previously. Not only that, the moderate is less than the high, or the fast, and more than the slow. So that suggests that slow speech decreases persuasion, fast speech increases it, okay? So there's kind of a linear effect going on here. But look what happens with high relevance. No differences owing to speech rate, okay? It's virtually a flat line, okay? That would support the hypothesis that speech rate only affects persuasion under conditions in which the message is low relevant, is not particularly relevant to the audience. So they take an easy route. They use the speech rate as a credibility cue, versus, so that happens under low relevance. Under high relevance, they don't pay much attention to the speech rate. They're tuned into the content. They want to analyze and systematically and carefully analyze what's in the message. So hence no effect for speech rate. So what this kind of pattern suggests, first of all, we have an important scientific qualification of our results. Speech rate, we know one of the conditions under which speech rate does affect persuasion and a condition under which it doesn't. Okay? And when the effect of one independent variable, speech rate, depends on the level of another, such as message relevance, when the effect of one independent variable depends on the level of the other, we call that an interaction effect, a statistical interaction effect. Okay, and that's basically what most researchers are looking for, because again, we want to know the conditions under which a hypothesis a relationship occurs or doesn't. And by knowing the conditions, we also get a little bit on the theory of why that's going on. Okay, so that's of what's going on. Now we know, we have more evidence, particularly if we took other measures that would sort of back up our thinking that, well, when there's relevance is low, we're going to get reliance on cues outside the message itself. When the relevance is high, people don't rely on things like speech rate. They look at the message content. So we've learned something, and we have some theoretical insight into why a relationship is happening. Okay. So the next section is just going to be on common research flaws. Okay. In other words, you have to be careful when you design research. Okay. And what are some of the things that we need to take into consideration here? Well, one is called experimenter bias. Okay. Demand characteristics. Sometimes when one does a study, the factors in the experiment kind of cue off people as to what the experiment is about, or what the experimenter, or what the hypothesis is, or just basically pull for responses, okay, that are not caused, okay, are not really caused by the independent variable that you're interested in. So, for example, studies have been done looking at defendant attractiveness as a factor in whether or not a mock jury is convicts or doesn't convict. Okay, some of these studies have been done in such a case where the attractiveness was manipulated in such an obvious way that people just basically got the message that, oh, they're interested in defendant attractiveness as a cause, and then they just went along with it. Okay. This is particularly a problem when we have experiments where people are exposed to the conditions of the experiment in more than one condition of the experiment. It's called the within participants procedure. So, for example, people read a number of vignettes when they're presented with a picture of the defendant, okay, and then they read about the trial, and then they're asked, do you think the person's guilty or not guilty? And half the time it's a really good-looking, very attractive defendant. The other half of the vignettes, it's very relatively unattractive individual. Well, that could cue off. That could be what we call a demand characteristic, and give people a clue as to what's being studied and what the expected response is. So one has to be careful to not to limit the number of demand characteristics that are involved in a procedure. Experimenter bias, expectancy effects. Okay, well, expectancy effects has to do with the idea that in unconscious, very subtle ways, okay, people who have expectation, be they experimenters, be they teachers, in any kind of situation, okay, our expectations about how someone will behave or what kind of person someone is or something like that can influence our behavior and create a self-fulfilling prophecy. Okay? So if we expect someone to be friendly, for example, we may behave in a very friendly way to begin with, and actually pull friendliness from the person. The person may act friendlier in response to our friendliness, so our hypothesis has been confirmed, which was implicit, not something we were explicitly thinking about, but mainly by our behavior. Okay, so it's called a self-fulfilling prophecy. Okay, so if experimenters know, for example, the hypothesis or how the theory is expecting people to behave in this particular condition of the experiment, then their knowledge of what the hypothesis is, of what their expectations of the behavior in this condition may actually cause them to behave in ways that basically pull for that behavior to occur. And therefore, it's not due to the independent variable. It could be due to their responses, could be due to the experimenter's own behavior. So we can even take an example from a study of animals, which was actually meant to demonstrate expectancy effects in people. So this was a classic study that was done in which graduate students, a number of graduate students, were given the task of training, okay, on a certain task, lab rats to run a maze. And so they said, go and train this rat. And by the way, the rat you were given, and half the people are told, is a maze smart rat. It's been breeded to be really smart, and others are, they're the offspring, and they've been breeded to be maze stupid. They're the offspring of rats that aren't particularly good at maze running and learning how to run mazes without going the wrong way, and so on and so forth. So half the people think that they're maze smart rats. The other students, smart people, think that they're maze stupid. Okay, but actually the rats came from the same colony, and they were randomly assigned to participants, to the students who are going to train them to run the mazes. And then they're told, okay, so let us know, give us a record of how long training took and things like that. Okay, and what was found was that invariably people who were told that they were training a maze smart rat, the rat learned better, okay, learned faster, made fewer errors than people who were told they were training a maze stupid rat. Okay, so you got this effect, and the question is why? And in all likelihood, it was experimenter bias, okay, associated with expectancy effects. Okay, and by expecting, so they expected the rat to do well, and they may have subtly treated them differently in one condition versus the other. Okay, maybe they were more relaxed, less nervous around in handling the maze smart rats than the maze stupid rats. They might have been more patient. Who knows? But we did get the expectation that your rat would learn fast led to the rat learning faster than rats for whom the expectation was that they were maze stupid. Okay, so now one of the solutions to expectancy effects is what we call double-blind testing. Okay, this is very, very important. Okay, double-blind testing basically involves not only, of course, the participant, the subjects in the experiment need to be blind, if you will, as to the purposes of the study, the kind of hypotheses they are, what the manipulations are, things like that. We wouldn't want their knowledge of that to influence how they behave. But not only the participant, but the experimenter ideally needs to be blind. In most research that's done, when it can be done, the person who's actually collecting the data does not know the condition that the participant is in, and may not even know what the hypothesis of the entire experiment is. Okay, so that they can't they can't communicate their expectations unconsciously and subtly. Okay, so double-blind testing is an extremely important factor that must be included in any kind of experimental study involving human experimenters. Okay, and most experimenters are, of course, human. Then there's participant bias. Okay, so one of the things that we might run into in doing an experiment is what's called impression management. Okay, people will, whenever we're under scrutiny, or we might believe that we're under scrutiny, we tend to want to act in ways that put our best foot forward. Okay, and our best foot forward might be based on what we think the experiment is about, what we think is being tested, and so the participants in the study may, in fact, make efforts to manage their impression, so not giving natural responses, but instead uh, responding in a way that they think communicates the best impression of them. Okay. In some cases, people, basically go right into a role if they've sort of figured out what in their mind what the study is about. They'll play a role that really isn't theirs. In fact, some research is actually based on role playing, where how so you might ask people, so how would you behave if you were in this situation, rather than actually putting them in that situation. And that typically doesn't work, role-playing studies, because number one, people give the responses that they think they would do, and they might not be in touch, as we've seen in our previous examples, with the kinds of causes of their behavior that are actually the true causes. But also in a role-playing situation, people are going to put their best foot forward and manage their impression. So that doesn't help us necessarily. Role-playing studies don't really work in this regard. They actually increase the possibility of impression management. Okay, we'll get to that in a second. But let me finish this thought about participant bias. How does one get around impression management? Well, psychologists have a term that they call psychological realism or experimental realism, that you try to design experiments that have a lot of realism involved, that are sufficiently engaging that people are responding naturally, okay, and spontaneously, that they're into it, that they get immersed in the experiment, and they're not thinking about how they should respond, okay, or how they're going to look good or bad or anything like that. They're just behaving. So experiments, one tries to design manipulations and procedures that create a lot of realism, a lot of immediacy, that the person is psychologically kind of like engaged, okay, and therefore acting naturally, and we're getting valid kinds of responses. We already talked about sampling bias a little bit when we were talking about surveys. We have to worry about bias selection. We need to do random and representative kinds of sampling. And we generally want larger samples versus smaller samples, and there are actually statistical procedures that exist to help, for example, pollsters determine how many participants they need, how many respondents they need in order to be able to get trustworthy, valid kinds of responses, okay? And generally larger samples, because there's always error in sampling. Error is then dispersed among a larger sample versus, if you just have a small sample, you could just by chance alone get some people who are weird from the point of view of what you're looking for. Okay. And I have this little table at the end, okay? And we're just about to the end of our story here, that you can look at as to some of the problems that exist in doing research, okay? We talked about experimenter bias. Here are the solutions, and there's also participant bias, which I don't have listed here. Well, that's over here. By the way, placebos. We didn't talk much about placebo, but your textbook does. So when we do just a good example is the examples um, of drug testing. Okay, so is it a valid study to do a study where you give one group of people the drug that's supposed to, I don't know, help them sleep better or improve something in their health, um, or in their mental health, and have another group just not get it? Okay, well, that's not a valid procedure, because just the expectation, the knowledge that you're taking a drug can influence your, um, you know, not only your psychology but your physiology. Okay, so so what virtually any decent drug study would do, and most experimental studies as well, would have a placebo control group. So a placebo control group is, they believe that they're told they're given the drug, but they're not actually given the drug. So now we can separate their improvement relative to the control and relative to the actual drug group, can be compared to see how much of whether it's totally a placebo effect, or what portion of the effect is due to expectation. And you can also have placebo issues with experimenters. Okay, if the experimenter knows that this person got the procedure and another condition didn't. Got briefly interrupted there, but basically the placebo condition is important for controlling experimenter bias, because in studies in which, for example, a physician knows that this person got the actual drug and another patient did not, they may treat them differently and do other things that could pull for the effectiveness of the drug, but it could be a placebo effect. Okay, other problem, ethnocentrism in research, cross-cultural sampling, and we talked about. So we have been through most of the issues with participant bias, and we see some of the solutions that we came up with. We should also talk about one way to also reduce that impression management kind of issue is to assure people, whoops, what happened here? Oops. Oh. I hit the return button too soon. But my final point was that confidentiality and anonymity is also an important factor in reducing impression management effects, or people responding in ways that they think are the better way to respond, or perhaps the safer way to respond if they don't want to reveal personal information. And of course, psychological research, some of it involves some deception. Often, for example, in our study with the high versus low relevance, that was a deception. And in order to, because there really wasn't such a proposal being thrown at people up there at issue at CUNY. And sometimes deception is necessary in order to do a manipulation or to keep people unaware of what the true interest is. And one should only use deception when it's absolutely necessary. And one way we get around, we deal with deception, okay, ethically, is that we have to make sure that we explain to people afterward, it's called debriefing, why they were deceived, okay, why it was important to do so, and apologize for deceiving them, and just basically make sure people leave the experiment understanding the importance of their participation. why the deception was necessary, and that it really was deception. This disabuse people of any beliefs that we might have had to instill as part of the experiment. We only use deception under the only when it's absolutely necessary. Okay, so we're done here, and I think this will be a good narrated lecture. May help you in thinking about some of the issues with one of the optional discussion item this week. In any case, that's it, and have a good day.